Does anybody need help on any of the problems from yesterday's assignment? Jamari?
7, because I got positive 4.
Perfect. Let's do 7. Sometimes my answer key could be wrong too. It's never a bad idea to ask for if you think yours is right. Who knows? It might be. So we're looking at the left side here, Jamari, and there's nothing to combine. There's on a variable term and a constant on the right side, nothing to combine. But I do need to get my variables on the same side, right? What did you do to get your variables on the same side?
I added 4R.
Perfect. So I'm going to add 4R as well. So that's going to go to 0. Did you forget your negative on your 11 by any chance? No, you remembered it? Nice. That's a pretty common mistake. So 8R plus 21. Okay. So negative 11 equals 8 times R plus 21. So what are we going to do next? No, that was where you made your mistake. So remember, the goal is to get by the solution, but also to get the variable by itself. We're going to undo multiplication, and we're going to undo addition, okay? So we have to always decide where the variable is, right? And that's a really common mistake, Jamari. So especially at the beginning of the year when we're reviewing, you haven't done this in a while. Just always remember, you always look to decide where the variable is to figure out what you're going to do next, okay? So here we're actually going to subtract 21. And so that's going to be negative 32 equals 8R. So if you did it the way you did it, you would not be moving anything away from the variable, right? You would be adding more stuff to it, and that's what we're trying to not do. So now 8 times R, we're going to undo that multiplication by dividing. So 1R, this is R, negative 32 divided by 8 is negative 4. Anybody else? Number 4? Number 4. So we didn't do an example with decimals in it yesterday, so this is a great one for you to ask about. But as we're looking at the left side, this is a variable term. This, even though it's a decimal, it's still a constant, and we can't add those, right? Same thing over here. This is a decimal. This is a variable term, so I can't subtract those. What I need to do is get both of these variable terms on the same side, right? 1.4 is smaller than, oh, I lied. So here's the tricky part about this one. What is the coefficient on that x? It's 1, right? So that is a negative 1, because it's minus 1x. So actually, this negative 1 is smaller than positive 1.4. So we want to add, in order to get our variables to the same side, we want to add x to both sides. And that's 1x, remember. So when we have negative x plus a positive x, that's going to go to 0. This leaves us 8.3 on the right side. And 1.4x plus 1x is 2.4x, and you can just add that on your calculator, plus 1, 1.1. Now, 2.4 times x plus 1.1. So I'm going to undo the plus first, and I'm going to do that by subtracting 1.1. So now I have left 2.4x, and that goes to 0. 8.3 minus 1.1, I think is 7.2, right? So far, so good? And now this is multiplied by that 2.4, so we're going to divide by that 2.4. Everything is exactly the same, even though it's got a decimal in it, but that's the beauty of being able to use our calculator. And I believe that should be 3. Anybody else? So number 8, nothing to combine here. But on the right side, I've got 2 x terms, so I can combine those. So I'm going to start by bringing down my left side. and then I'm going to combine these x's. 7x's minus 1x is, yes, 6x. And I bring down the plus 12. So now I've got x terms on both sides. Nothing else to combine. So how am I going to get the x's on the same side? I am going to move it. That's right. How do we move it? We could minus 6x. But if we subtract 6x from both sides, now we're going to have a negative number to work with. A manual, right? So let's always look for the smallest coefficient, and let's do the opposite of that one. Let's subtract the 4x instead. That way, we don't wind up with a negative number on our x, negative coefficient. So that's going to go away. 0 minus 9 is negative 9. 6x minus 4x is 2x. And bring down the plus 12. So now it's negative 9 equals 2 times x plus 12. We're going to undo the plus 12. How do we undo the plus 12? Yes, minus 12 from both sides. So we have negative 41 equals 2x. How do we undo the multiplication? Emmanuel, how do we undo the multiplication? Yes. Multiply by 2, we divide by 2. If we're multiplied by negative 2, we divide by negative 2. All right, so that simplifies to 1x. I'm going to put it on the left side. And I'm going to leave this in that form. It's perfectly acceptable in that form. Remember, if you're not sure it's simplified, you can put it in your calculator. We have a button for that. If you put negative 21 halves in your calculator, it's going to turn it into a mixed number for you. You can give me the answer as a mixed number if you like. But you can also just leave it like that. Yes. Yeah, if there's a decimal in the problem, like in number 4, a decimal answer would be okay. But like in number 8, there's not a decimal in that original equation. So while a decimal would be an equivalent answer, we're going to leave it in fraction form. Okay? So if there's a decimal in the problem, you can give me a decimal in the answer. If there's not a decimal in the answer, and you come up with a fraction or not a whole number, we're going to leave it as a fraction. Okay? If you gave me the decimal in a test, I would probably take off a half a point. Because sometimes I want you to practice using fraction form. Sometimes I want you to use a decimal. One of the common times we would almost always use a decimal in a real world problem or a word problem, we'd be more likely to use a decimal. Okay? But if it's just a plain straight up equation, if it's not a decimal in the problem, we're not going to give a decimal answer. What do you think? Any other questions on yesterday's assignment? Okay, well let's go ahead and pass these out. I told you could turn in the first several days things on paper. So we'll pass those up. Thank you for making 2 piles for me, my line leaders.
How do you feel about the and
Oh no, that's fine. So Mrs. Rayleigh made these directions and she makes her kids keep a notebook. I'm not that organized. I can't grade the notebook. It's too hard. But in my defense, that's one of the reasons why I have you scan your notes. Because if you scan your notes, you never lose them. And that's the purpose of the notebook, right? So you can just use the top one for the date, and I don't need the other one. But put your name on it. We're going to put that instead. Yeah. Who do you have the first? Okay, yeah. And I said, you want me to turn this stuff in down? No, you have it? Oh, yeah. So if you have it, you can turn it in. Yeah. Okay, yeah. Okay, so, you're turning in the notes and you're turning in the worksheet. If you didn't turn in your 2 truths and a lie, you can also turn that in today for full credit. Make sure your name are on your notes. I had several people in first period turn in their notes with no name. Okay, so you keep that and finish it, okay? You can keep that as well, in case it helps you with that. So turn them both in tomorrow. So I am flexible with due dates right now because it's the first week, but by the end of this week, I'm going to expect you guys to get your stuff turned in on time, all right? So after this week, I'm going to expect things in on time. Maybe I make some exceptions still the second week, but I need your mindset to be, I got to turn my work in on time. Because remember, after the second week, do I take late work? No. Now I'll drop 2 days in case there's something out of your control or just a bad day. I'll drop your 2 lowest grades in the assignment category, but we don't take late work after the second week. Okay? And I really want to try not to turn our work in late next week either. Okay? This week, whatever we got to do to get it turned in. Next week, it should be turned in on time. And if you have a little problem, that's okay. Turn it in the next day. But the third week, I'm going to hold you to the due date for time and everything. So remember, digital submission by 7 a.m. the next day, unless I tell you different. If you turn it in by 7:30, I'll still give you full credit. That way, if you get stuck, you're having a technology problem at home, and you need to get on campus to scan and submit, then you got 30 minutes to do that, right? So that is the goal for that. Okay, if you didn't finish your worksheet and you kept it, that's good. I want you to finish it and turn it in so I can give you full credit. If you don't get 100 on it, and I'm going to try to pass things back tomorrow, anything this week, if you don't get a 100 on it, fix it, and I'll let you have full credit. All right? But like I said, that will stop pretty soon. Okay, we are going to go ahead and get started. We are still solving multi-step equations, but today our multi-step equations are going to have fractions in them, and we all love fractions, right? No. Tell the truth. Nobody likes fractions. So here's the thing. If our equation has a fraction in it, we're going to get rid of the fraction right away. First thing. Okay? And so that's what we're going to start with today. All of our equations are going to have fractions in them. I think I've got a typo in here, so let me go ahead and fix this real quick. Okay, so most of this stuff you have already filled in, okay? You have, the notes you have say all of these things. When I write something extra, you're also going to write that extra, okay? So I do have some new guys, so just to be clear, we do have notes for every new section, and just like Mr. Hunley, I'm sure you just have to write everything I write. I don't even know if he grades notes or not, but I do grades for notes, at least for now. Eventually I might stop grading them, and I'm trying to give you guys some incentive to take your notes and be diligent with them. So at first, I'm going to give you credit for just taking the notes, okay? So that should help your grade. So to get rid of fractions, we need a strategy. Our strategy is to find the smallest number that all the denominators can go into. Right? The smallest number that they all can go into. And that's going to also be known as the least common multiple. So you can think about it as a least common multiple, or you can think about them all needing to be factors of this number. So the smallest number that more than one number will go into is the least common multiple, right? So what is the smallest number that 2 and 3 are both a factor of? Is 3 a factor of 4? No. What did you say? 6. This is the smallest number that 2 and 3 will go into. Now here's the thing. will 2 and 3 go into 12? It will. And we could use 12. Our goal is to find the smallest number. But I will tell you, as long as these numbers are factors, you can use that too. But right now we're looking for the smallest number that they're both a factor of. What's the smallest number that 3 and 5 are both a factor of? So that would be the least common multiple. So do you guys know what a multiple is? Can anybody count by 3 for me? Can you count by 3? Anyone? Can you count by 2? Let me hear somebody just blurt it out. Count by 2. 4, 6, 8, 10. So what you're doing when you're counting by 2, those are the multiples of 2. 2, 4, 6, 8, 10, 12. Those are all multiples of 2. That first number you start with, all the numbers after are multiples of that number, right? So multiples of 3, we count by 3. 3, 6, 9, 12, 15, right? But the thing is, the numbers below that last number are factors as well. So anyway, you can think about it either way. Sometimes what makes sense to Leo might not make sense to Tiana, right? So thinking about it a different way sometimes helps. So what is the smallest number that both 4 and 6 will go into? 24 is the multiple. Is it the smallest multiple? What was it, Leo? 12, yeah. So Tiana, you could use 24 to get rid of the fractions, right? But 12 is the smallest. How about 7 and 7? 49. So 14 would work. For our purposes, 49 would work. But the smallest number that they're both a factor of is 7, right? So if you have 2 fractions and both the denominators are the same number, it's just that denominator, right? If you only have 1 fraction, whatever the denominator is, that's what you would use. So 7 is the least common multiple. What's the smallest number that 2 and 9 would go into? 18. And what if we had 3 fractions or 3 numbers? What's the smallest number that 2, 3, and 5 are all a factor of? 30. 30 is right. 2 is not a factor of 15, right? So you were on the right track. You would eventually have gotten there. But 30 is right. 30 is the smallest number that they're all a factor of. And 30 is the smallest number if you count by 2, if you count by 3, if you count by 5. The first number that you get to when you count by all those, that they have the same, will be the 30. Yes? They're okay, baby. You're supposed to grab them when you come in. Remember, it says grab your calculator, pick up papers. Okay. So once we've decided, let me write this in here. Once we've decided that we know what the least common multiple is, now we are going to use that number, and we are going to multiply all the terms in the equation by it, and then solve. Because when we multiply all the terms in the equation by the least common multiple of the denominator, then we get rid of the fraction. Okay? Multiplying by fractions is easy. Adding and subtracting fractions, that's the time-consuming, tedious part. So we are going to multiply a number by the fractions, and then they'll be gone. So you're writing, the only things that you had to add were this, and the numbers. All right, y'all caught up with me? Okay. So, we are going to start. See, this is an equation. There are 2 fractions. What are the denominators in this equation? 3 and 6, right? So let's find the least common multiple of those denominators. I heard somebody say it. What's the least common? Go ahead. 6, that's right. 3 times 2 is 6. 6 times 1 is 6. 6 is what we're going to multiply everything by. We're going to do this. or multiply by 6, so since we're multiplying it by fractions, we're going to make it a fraction just by putting it over 1. So multiplying everything in this equation, so I'm going to use arrows. 6 times 2 is 12. 1 times 3 is 3. And that is the coefficient of x, so I can't forget to bring my x. So you're thinking, wait, multiplying is supposed to have gotten rid of the fraction. I just wrote a fraction, right? Well, what is 12 divided by 3? 4, right? So below that, let's just go ahead and write 4x. So let's go, it's plus, and now we have 6 times 5, we're going to multiply 6 by the 5, 6, so 6 times 5 is 30, yeah, sorry, I'm getting really sorry, go on, sorry. I'm trying to move around to be around everybody, but we'll be back soon. Alright, and 1 times 6 is 6. So once again, I'm trying to get rid of a fraction, and yet I just wrote a fraction. But what is 30 divided by 6? Right, so let's go ahead and bring that down plus 5 equals. And I have to multiply by everything and everything on the other side of the equal sign. So I'm going to go 6 times negative 3 is negative 18. That's x, and I don't have to do anything with that. I'm just going to go ahead and bring that down. I have to see what you multiplied it by to get rid of the fraction. I would like to see this step, but if you're somebody that is pretty good at that and you can do it in your head, you could give me just this step. I would caution you though, be careful. Maybe start with this step and once you practice a little bit, if you want to cut it out, you can, but I would encourage you to write it. The more work you show, the less mistakes you make. I know you guys, a lot of people don't believe me, but it is true. Okay, now we have an equation just like the ones we solved yesterday. Nothing to combine on this side, but we do have to get the variables on the same side. How do you get the variables on the same side? What do you think, Misha? What would you do? Oh, very good. Good thing. I would add 18x. There's a couple ways to do it, but best practice is to look at those variable terms. The smallest coefficient is the one we really want to move. So I want to move this negative 18x because it's smaller than the 4x. So I'm going to add positive 18x here as well. Now I have 22x plus 5 equals 0. Because negative 18x plus 18x, those are opposites, remember? We have the same thing, but one is positive and one is negative. We say that those are opposites. And when you combine opposites, you always get 0. So now we're going to choose an equation that looks just like the one we solved yesterday. 22 times x plus 5. What do we do first, Carlin? Do we undo the adding first or the multiplying first? Yes. So we're going to subtract 5. That's how we undo the adding. And what we have left here is 22x equals negative 5. So I'm going to undo that multiplication by dividing. So remember, we're not going to turn this into a decimal. We're just going to leave it as that simplified fraction. Any questions on that? Okay. Ready to move on to example 2? All right, so two fractions. The denominators are 3 and 2, right? What's the least common multiple here? 6 again. So we're going to multiply everything by 6. And since we're multiplying it by a fraction, we're going to put it over 1. Okay. Can't forget, we've got 4 terms, so we should have 4 things to multiply by. This, and this. So we're going to start. 6 times 5 is 30. trying to get rid of a fraction, but we know a fraction. But what is 30 divided by 3? Okay, so let's go to write, that's the same as 10x, right? Plus 6 times 2 is 12. Nothing to do there, we can go ahead and bring that down. Equals 6 times 4, 24. Not a fraction there, so let's go ahead and put that down there. Minus 6 times 1 is 6. 1 times 2 is 2, and that's an x. But what is 6 divided by 2? Right, so minus 3x. So now we did the easy work with fractions, which is multiplying. Multiplying is the easiest thing to do with fractions. We multiply them away. So now we are going to go through. We have variable terms on both sides. Negative 3 is smaller than 10x. So we're going to move that one. We're going to move that one by adding 3x to both sides. So that's 13x plus 12 equals 24. You should be able to solve it from here. 13 times x plus 12. We're going to undo the adding first by subtracting. 13x equals 12. Undoing the multiplication by dividing. And what we wind up with, 13 divided by 13 is 1x, so x equals 12 13. There's not a decimal in the problem, so we're just going to leave it as that fraction, that simplified fraction. Any questions? And I think we have one more. Nice. All right. A lot of fractions here. After we'll do the next 2 minutes, two problems. As long as we still have 10 minutes left in class, and I know get to the last 10 minutes. But we're going to finish our notes first. All right. I've got a 4, an 8, a 2, and a 4. Very good. I heard somebody say it. 8. All of these numbers are a factor of 8, and all of these numbers, 8 is a multiple of those numbers. So, we are going to multiply everything by 8. So we're going to put number 1 since we're multiplying it by a fraction. You keep it up with me on this? So it's going to start. 8 times 3, 24. 1 times 4 is 4. Got an A, we can't forget it. Should be able to divide this away, right? We are getting rid of the fraction. So 24 divided by 4 is? Right. So if you get to this point and that fraction doesn't go away, if you can't simplify that, then you've either picked the wrong multiple or you've done your math wrong, right? So check it with your calculator. If the fraction doesn't disappear, then you haven't used the right multiple. You haven't used a multiple, okay? There's not a right or wrong multiple. We are looking for the smallest one, but you can use any multiple. But if it's not a multiple, it won't get rid of the fraction. All right, so 8 times 5, 8. So 8 times 5 is plus, by the way. That's 40 over 1 times 8, which is 8. That fraction can be simplified to 5. Equals is next. Now, what am I multiplying by here? What am I multiplying 8 by? Very good. There's a coefficient of 1 there that we don't write. 8 times 1 is 8. And 1 times 2 is 2. There's an A there. What does that simplify to? 8 divided by 2 is 4. Yeah, 4A. Minus. And 8 times 1 is 8. Over 1 times 4 is 4. And that's going to simplify to 2. Very good. So, combine already, but we do have to get our variables in the big track. 4 is smaller than 6, so we're going to move it by subtraction. So that's going to be 2a plus 5 equals, the whole idea was to get that to 0. When it is 0, so 0 minus 2 is negative 2. It's 2 times a plus 5. What do we get rid of first? The multiplication or the addition? Addition. Get rid of addition by subtracting, so that's what we're going to do. So that was simplified to 0. 2a equals negative 7. Be careful, sometimes people subtract that. Subtract a negative, right? But it is a subtraction. Negative 2 minus 5 is negative 7. And under the multiplying by 2 or dividing by 2. So 1a equals negative 7 halves. So we're going to multiply it. Very messy. And one more. Got any questions on this one? No? Follow with me? All right. Denominator 3, denominator 3. Supposed to become a multiple of the same number as that number. So we're just going to multiply everything by 3. So I'm going a little bit faster because it's the fourth one. We're not really doing anything different. Remember, don't forget the x, so that's going to simplify to 2x, right? 6 divided by 3 is 2, there's a plus. 3 times 4 is 12. Nothing to simplify, so I'm going to bring it down to my equation that I'm actually going to solve from. And equals. And now we're going to multiply 3 by the 8 thirds. So 3 times 8 is 4. 1 times 3 is 3. That is the coefficient of x. We can't forget it. What does that simplify to? Minus. What am I multiplying the 3 by? 1. Very good. 3x. And that 3x down. Nothing to think about on the left side. I do a variable term. I have 2 variable terms here, so I need to combine this before I get the variables on the same side. So that's going to simplify to 5x. You have 8 x's, and you subtract 3 x's, you have 5 x's, 5 times x. So I'm going to move these x's over here by adding the opposite, or I would be subtracting in this case. So the whole intention of moving, the way we move it is to zero that out. 0 plus 12 is 12 equals 3x. 3 times x, right? We're going to undo that time by dividing. 1x equals 12 divided by 3, which is 4. So maybe we'll take an emergency, go real quick, it'll stop, just try to wait. You guys can go ahead and get started on your worksheet. We won't pack up until 49 or until they announce it starts. Go ahead and start working on it. I can help you if you need a little bit of help as we go. Yes. Yes. Yeah, and this is the one that video will work for this one and the one you didn't finish. Something like that. Yeah, there's a video for this, so you're gonna wanna, this is good, but all this down here needs some more work. So look at the video and you'll have all that work. Oh, okay, good job. I would like a little bit more detail, so just fast forward to the end of the video and you can see that stuff, okay? Good job for you for finding that document though. Lillian, you need the stuff from yesterday, or did you get it already? There's only one fraction? It's a great question. Lillian asked, what do we do if there's only one fraction? Well, that one denominator is what we'll use to multiply by. So for instance, number one only has one fraction. The denominator in that fraction is 6, we just multiply everything by 6. It is, it's perfect. Stop my recording and let me know if you need help. I'll come around and help you.